Okay, let's continue our discussion then. So we'll next look at the small intestine. So after the food is processed by the stomach, it next goes to your small intestine. And as you know, the small intestine has three regions to it. It has so your stomach empties the food into your duodenum of the small intestine, which then pushes the food into the jejunum of the small intestine, and then it finally is pushed into the ileum of the small intestine, which will then carry the processed chyme into your large intestine, what's called your cecum of the large intestine. So here in the duodenum, we want to point out that this is the area where you receive chyme from stomach. You also have your, if you recall, this is your duodenum, like this. And then you had your pancreas, like so. Then you also had your bile from the liver coming down as well, like this. So this is bile duct carrying bile from the liver, meeting with your main pancreatic duct, carrying enzymes from the pancreas, and they meet here in an area called your hepatopancreatic ampulla. And then from there, it moves into your major duodenal papilla. And you also had a minor duodenal papilla that only gets enzymes from the pancreas as well as bicarbonate. No bile comes from this one. Bile and enzyme both go into the major papilla. It's minor duodenal papilla. And up here, this is where chyme comes from. So chyme from the stomach enters, of course, through your pyloric sphincter to enter into the duodenum. So it's a very critical part of the small intestine is the duodenum to receive chyme from the stomach as well as enzymes and bile from your accessory organs. Now, the small intestine overall, especially in the jejunum and ileum, has the job of absorbing or chemically digesting your food as well as to absorb it. So we're going to look at some of the modifications of the mucosa of the small intestine that allows for you to do so. So in the small intestine, so you have these modified. So this is the lumen of the small intestine. It has these circular folds in it, and these circular folds inside the mucosa called your plicae circularis. Those circular folds help to slow down the chyme. So the chyme must do this, flow like this through it, so it's not rushing through. So it slows down chyme to give more time for you to digest it chemically, physically, and also to absorb it before it runs through the small intestine. Also here you have these structures called villi that are found on these plicae circularis. So these call your intestinal villus. So your intestinal villus is also a modification found inside your small intestine where you have cells on the villus like these. Okay. And these cells come in two types. You have your absorptive cells. Their job is to absorb nutrients. Then you have your goblet cells. And these cells make mucus, okay? And on top of your absorptive cells, you have this fuzzy border called microvilli, also called the brush border. These make enzymes called brush border enzymes which are critical in digestion. So this is the microvilli, also called the brush border, okay? And they're only on top of the absorptive cells, not on top of the goblet cells. And in the center of each villus, then you have a system of blood vessels and capillaries. So here you can have an arteriole will enter it, and it will go through a capillary bed, a fenestrated capillary bed that's leaky, and then it's drained by a venule, like so. Okay, drained into your hepatic portal system, and then so you will have many capillaries inside the core. Okay. And then you have another structure called, so these are the label for you. So these are capillaries. These are fenestrated capillaries, meaning they're leaky, there's less stuff in them. And then you have, down the middle of it is another lymphatic structure called a lacteal. Very porous structure to let fats in it. So from, say, your lumen of the stomach, you know, things like amino acids can be brought in to the absorptive cells and released into the lumen into the core of the villus, where it will then find its way into your capillaries, and now it's in your blood, okay? Whereas your fats, you know, your triglycerides, your triglycerides or your fats, okay, will come in and eventually find their way into the lacteals. And then it's absorbed that way. So your capillaries are mostly for fatty acids, for your amino acids and your carbohydrates, while the lacteals are for the fats. Lacteals will dump the fat back into your subclavian vein, thereby getting it back into the blood. This one will dump the nutrients into your hepatic portal system, which carries the blood to your liver, where it's processed. So you have two modifications, your villus as well as your plica circularis, that helps to slow the chyme down. And both of these allow for the small intestine to do its job of chemically digesting the food as well as to absorb the food into your blood, so you can use it. Okay. All right. Let's briefly hit a little bit more back on this idea of the liver here. So the liver, which is we call an accessory organ, the liver's main job in terms of digestion, at least in a very simplified way, it makes bile, produces bile at a rate of about 500 to 1,000 mLs per day. So it's a lot of bile. And that bile is necessary to what's called emulsify fat, meaning that it takes a fat that's this big and produce fats that's small like this. So it breaks fat down physically into smaller bits that can be, this is called emulsification, breaking big fat into small fats. That's what bile does for you. And bile is released from the liver or the gallbladder in response to CCK, which is made by your duodenum. When there's fat in the chyme that enters the duodenum, it makes CCK to tell the liver to send bile down because fat is now down here to be used. Okay, so that's how it's done, how the bile works, and why it's released when it's released. Okay, all right, we'll pause there and then we'll hit the pancreas next.